Hi, this is Mrs. Clark, and welcome to my video on solving inequality word problems. This page is going to go into our interactive student notebook, so follow along with me and we'll solve these problems together. So the first one I've already annotated because we did the same example in our ISN RRA paper. So I've noted that at most means less than or equal to for $45. So we're spending less than $45 or exactly equal to $45. She already bought a $15 yoga ball. So I know that's going to be 15 plus something else, whatever else she's going to buy. And I want to write an inequality. So that's either a greater than or a less than statement to show how much she can still spend on her friend's gift. So I want to find out how much she can still spend. So that's going to be my variable, my x. And I want to solve this inequality, get a solution, and I want to graph it down here on the number line. So my solution's going to go here, whatever I get when I solve. And then my graph is going to go here, and then I'm going to have to answer this question. So first thing I need to do is write my inequality. Well, I've already done some of it. I know that whatever she buys has to be less than or equal to $45. I know that she's buying a yoga ball plus something else, and that something else I'm calling X because I don't know how much money she has left to spend, but I know she's going to spend it on the rest of her gift. So right there, I have an idea that her yoga ball plus whatever else she's going to buy is going to be less than or equal to $45. So right here under inequality, I'm going to write that 15 plus X is going to be less than or equal to 45. So there's our inequality statement. Yoga ball plus whatever else she buys has to be less than or equal to $45 because we cannot spend any more than what we have. So now on this section under work, we're going to actually go and solve it. So I'm going to actually rewrite it here just so I can show my inverse operations underneath it. Anytime I solve an equation or an inequality, I'm going to do the inverse. So I'm trying to figure out what x is. I'm trying to figure out how much money we have left to spend. This is a very simple inequality, so I know it's easy for us to just look at it and sometimes reason it out, but we're going to show our inverse operations. So 15 is being added to x. It's a positive 15, so I'm going to subtract 15 on both sides. Over here, my 15s are going to cancel out. I'm going to get x is less than or equal to 45 minus 15, which is 30. So that is my solution. So I'm going to go ahead and put that up here as my solution. X is less than or equal to 30. And I'm going to graph that here. I'm going to fill in my number line. So I'm going to put 30 here. So I'm going to do 31, 32, 33, go down 29, 28, 27. So if I want less than or equal to 30, I'm going to fill in my circle at 30. Because just like we have here, when I'm looking at less than or equal to, we have a closed circle. And I'm going to go where the numbers are less than 30. So that would be 29, 28, 27. That's this direction. So I'm going to shade there to show my solution on my paper. Now, forgive me, this paper is kind of tie-dyed. One of my children spilled stuff in my work bag and wrinkled my paper. Anyway, we're going to now answer this last question. What does this solution to the inequality mean? So I want to know, what does this answer, x is less than or equal to 30, mean in our story problem? So Allie, I want to know, what does that mean about Allie? So what are we trying to figure out here? X is how much she can still spend on her friend's gift. So at this point, she can still spend less than or equal to $30. So we can say, in a few ways we could say it, but I'm going to say Allie has at most $30 that she can spend on the remainder of her friend's gift. Now you could also say she can spend $30 or less. So there's a few different ways you can word that. You choose how to word it, but what we're doing here is important. The important piece that we're doing here is that we're taking the numerical answer that we got and we're bringing it back to the word problem. So we're giving those numbers some real life meaning. And that's going to be our criterion D, which is applying math to the real world. So why are we even learning how to solve these inequalities? Well, now we can actually solve some real life problems. Now, these are very simple real life word problems as a way to get us started, to get our feet wet into these situations. So if I look at the second one, I didn't annotate this one yet, so we can do it together as we read it. Now, Allie has at most $45 to spend on her friend's birthday gifts. This is the same problem that we did in our notes page. She already bought her a $15 yoga ball, so same as before, but her grandma says that she can only spend half of the remaining money. Write an inequality to show how much she can still spend on her friend's gift, then solve the inequality and graph the solution. So we have Allie has at most $45 to spend, so that's less than or equal to 45. Oh, let me do a 45 here, no dollar sign. She already bought her a yoga ball for $15, so that's $15 so far, plus whatever else she's going to buy. But her grandma says that she can only spend half of the remaining money. So if we're trying to spend only half of the remaining money, we're going to call that X, so that the amount that's left over we can spend is X. And we're going to write an inequality to show this whole situation. So we have to think about, how do these things all work together to be less than or equal to 45? We need to write that inequality, right? So we need to write a statement, something less than something. And we need to have the answer be how much she can still spend on her friend's gift. That's my X again. And then we're going to solve that, put our solution here, and then we're going to graph our solution down here. And we're going to answer this last question. So if we think about how these things work together, we know that we have bought a yoga ball, so 15, plus she's going to buy something else, plus we're going to have money that we're going to give back to grandma. So we know that it's $15 for the yoga ball, plus she's going to buy something for her friend using half of the remaining money. But then the other half of the remaining money is going to go back to grandma. So we have this half on the gift, and then this half to grandma, because she can't spend it. And together that's going to equal less than or equal to, not equal, 45. So that means the remaining money is going to be X. So that the remaining money is going to be these two things together, two X's. Because X is going to go to the gift and the other X is going to go to grandma. So when I take the remaining money and I split it in half, half will go here and half will go there. But because I labeled the remaining money as X instead of because I labeled the half of the remaining money as X, that means the other half is also X. So the total amount of remaining money that we have is really 2X. So you can think of it as when I see half in this problem, this is going to tell me that I have to do times 2. It's the inverse of what I would normally think. Because I want that half to be labeled as my variable, so that has to be doubled to go back to what the remaining was. So if we think of it logically, yoga ball, which was 15, plus the gift, plus the part I'm giving back to grandma, which these are equal parts, right? Because the remaining money was split in half, has to be less than or equal to 45. So there we get 15 plus 2X is less than or equal to 45. This will get easier as we do more problems. I know it's just the first time you're seeing something like this, so it's a little bit odd for now. But we've done problems like this before, and we've solved them, no problem. So now if I want to figure out exactly how much money we have to spend, Allie can spend on her friend's gift, the remaining part. It's also going to be the same amount of money she's going to give back to her grandma. We can solve this using our inverse operations. So again, just like before, we're going to take off this money that we spent on the yoga ball so we can figure out what's left to spend. So it's a positive 15. I'm going to subtract 15 on both sides. So I'm going to cancel those out, and I'm going to get 2X is less than 30. So 30 is the remaining money, but grandma says we can only spend half of it, so we have to divide it in half. When we do that, we get x is less than or equal to 15. So $15 is going to go back to grandma, and $15 can be spent on the gift. So my solution is x is less than or equal to 15. I'm going to graph it. I'm going to make this a 15 here. So 16, 17, 18, 14, 13, 12. Fill it in the circle on 15. It's less than or equal to, so it's going to go this way, where the numbers are smaller than 15. And what does x less than or equal to 15 mean? It means that Allie has $15 to spend on the rest of her friend's gift and $15 left over to give back to grandma. Okay, so that last part is very important to make sure that we're making sense of our answer. We're not just arbitrarily solving these inequalities, but we're actually bringing them back to our word problem, making some meaning to these numbers. And so one part that I left out here is I wrote that Allie has $15 to spend, but she has $15 or less. So let's add in an or less here, because we really want to talk about not just that it's equal to 15, but that she could spend less than 15 as well. That means she has $15 or more to give back to grandma, depending on what she spends. If she spends exactly 15, it'll be 15, 15. If she spends less than 15, it'll be more than 15 to give back to grandma. So those pieces are important. We're going to go ahead and put this into your notebook. So I would say for this paper, let's fold it in half, maybe almost in half like this. Glue this into your notebook this way. That way your title is showing. And go ahead and glue that in so you have it to go back and look at for our annotations and our examples that we've done, as well as how we explained our solutions. Let me know if you have any questions, and if not, you can go ahead and move on to some practice on these word problems. Thanks again for watching.